This video is designed to show you how to use SPSS to conduct a multiple regression analysis. For this example, we'll use the Chapter 14 data that uses physics as the dependent variable and gender, emotional intelligence, IQ, verbal SAT, and math SAT as independent variables that will predict or explain physics scores. In order to do this analysis, then we'll go to Analyze, Regression, and Linear. And so what we're going to do is move physics into the dependent variable box, and we'll move gender, emotional intelligence, IQ, verbal SAT, and math SAT into the independent variable box. For the statistics, we want to check descriptives because that will give us the means, the standard deviations, and the correlation coefficients. And then we'll check part and partial correlations and collinearity diagnostics. Then we'll click Continue. And then under Save, what we want to do is click on the standardized residuals, because that's one of the regression diagnostic pieces of information that we like to have when evaluating our multiple regression model. And then we'll also want to check Mahalanobis, Cook's, and leverage values. And then we'll go to Continue. And then under Options, I think everything that is checked that we want. And then we'll click on Continue, and then we'll click on OK to run the analysis. And you can see that in this analysis now, we have our means, our standard deviations for each variable, and then the number in each, the number of individuals or cases. Then we have our correlation matrix, and our correlation matrix is important because it provides information that can help us detect multicollinearity. So what we're going to be looking at is to see how highly correlated these independent variables are with each other. And we also like to just see how what the correlations are between each of the independent variables and the dependent variable. So our highest correlation between physics and an independent variable is for math SAT 0.690, and our smallest correlation is with verbal SAT and math, verbal SAT and physics scores, and that correlation is negative 0.192. Remember, we interpret the absolute value for the magnitude of the correlation. The next part of the analysis that we want to look at is the model summary. And in this case, our model summary tells us that our coefficient of determination, R, is 0.897, or almost 0.8, or 0.90. And so this squared comes out to 0.805. Or we can say that approximately 81% of the variability in physics scores is due to the linear combination of gender, emotional intelligence, IQ, verbal SAT, and math SAT. And then our ANOVA summary table tells us that the regression equation is explaining a significant proportion of variability in physics scores, or a significant portion of physics scores. Then we have our coefficients for our analysis, and in this case we see that for each of our independent variables we have our unstandardized betas, we have our standardized beta coefficients, the t-ratios, and then the significance of each one of those particular independent variables. We also have the zero order correlations, which are the same as the Pearson correlations, but then I also checked so that we would obtain the partial and the part correlations. And again, these correlations can help us interpret each of these independent variables and how they influence physics scores apart from the other independent variables. And lastly, on this coefficients table, we see the tolerance values. And again, the tolerance values are designed to help us evaluate for collinearity or multicollinearity. And so values that are close to 0 indicate that we may have high collinearity between one independent variable and other independent variables. And then we have our residual statistics, and I'm not so concerned that we look at those in terms of our evaluating for multivariate outliers. But what we want to do then is toggle back to our spreadsheet so we can see the values that we've obtained for our multivariate outliers. The first one we obtained is the z of the residuals, and so this tells us about how large our errors are. And one of the indicators of multivariate outliers is if we have residual values that are greater than 1.96, and you can see we have several. Okay, this one 2.12 minus 2.33. So these are ones that we would want to definitely look at. And then we have our Mahalanobis distances. That's like a leverage value, and so we'll want to evaluate those as well as Cook's distance. And then we have another form of leverage value that we can look at in terms of our multivariate outliers. So this information then will be what we'll be using in class to interpret and evaluate our multiple regression model when we analyze the Chapter 14 data.